Hey, hello, and welcome to the show. It's me, John Park, and you are here for John Park's workshop, and so am I. And so is Lars. We're all here. It's so fun to have everyone in the workshop today to get together and build some stuff and show some things. Let's see, what else is going on? First of all, who am I talking to? You may wonder, I'm talking to our chats. So we've got chat over in the YouTube land, hello everyone there, and also over on our Discord. So if you're somewhere else and you're wondering, hey, where is the chat? Well, that's it right there. That's the Adafruit Discord server. You can get there by heading over to adafruit.it/discord. Look for the live broadcast chat channel, and that's what's going on in there. Let's see, what else? Hold on one second, I'm just gonna fix some semi-broken things here. Let's go, I'll make that smaller. There we go. Just like that. There's our chat. And what else? So we've got a action-packed show for you today, and by we I mean me. I've got fun stuff I think I'm excited about. But before I get into that, I wanted to give you a coupon code that you could use today if you wanted to go buy some stuff in the Adafruit store. Maybe you'll want to do it later. Maybe you want to do it at all. There's no pressure. But I'll show some stuff that I'm using for my arcade board project that is Adafruit goodies that you can go get. And this coupon code today, JAMMA, J-A-M-M-A, that'll get you 10% off in the store. So just head over to Adafruit, and hey, look, there's some arcade stuff right there. In fact, we have a lot of arcade stuff. If you go and just do a search, arcade, you'll see loads and loads of buttons and wiring harnesses and joysticks and on. Lots of buttons, lots and lots of buttons. This small arcade joystick, I'm going to use one of these today, actually. Unfortunately, we're all sold out at the moment, but that's a nice little stick. I've used that in a number of projects. We've got light-up buttons. We've got regular non-light-up buttons. So if you're looking for that kind of stuff, or who knows, anything else, go ahead and type in 10% off. Go ahead and type in JAMMA, that is, for 10% off in the Adafruit store. I mentioned this last week, and I got the name wrong. Let me check my notes, because I think I'll get the right name here today. JAMMA stands for, oh, I didn't write it in this set of notes, did I? It's Japan Amusement Machine and Marketing Association. Japan Amusement Machine and Marketing Association. They do a lot of things, but one of the things they did back in around 1985 was got together and came up with a fairly standard setup for arcade peripherals and connectors so that arcade operators could keep a cabinet, everything, swap in a new game just with the PCB board and hook it into a known system. Before that, every game was kind of customized as far as what wiring harness for joysticks and coin acceptors and lighting on the marquee and power supply, all that stuff was all over the place. So JAMA, they're the ones who made a standard that I think still stands today. I think it's still in use. So JAMA, that'll get you 10% off in the store today. I'm not associated with the JAMA. I just like the word, honestly. So what else? Let's talk about the show I do on Tuesdays. That's the product pick of the week. There's the logo right there, JP's product pick of the week. I like to grab something new or something old, or in this week's case, something that was old that is new again because it's back in stock. We got plenty of them. And that's this guy right here, the Cutie Pi with the M0 on it. And I give you a 50% off typically. So there's 50% off for these boards on Tuesday if you're watching during the show. So tune in while JP's product pick of the week is happening, which is 4 o'clock Eastern time, United States Eastern time, allowing for daylight savings changes and things. So use your computer to find out when that is in your local time. And the thing I like to do afterwards is condense it down to a little 1-minute segment that you can enjoy right here, right now. So here it is. That's my product pick of the week this week. It is the return of the Cutie Pi SAMD21. Some of the things I love about it: 1, USB-C. 2, the fact that it is USB HID compliant all the way through, so you can do MIDI projects with it, keyboard projects with it, mouse projects with it. Also, because of the Stemma QT port on there, you can plug in the many I2C peripherals that are available out there, and especially the ones that have that Stemma QT port. It makes it plug and play. WeChuck adapter lets you use various Nintendo accessories, and a little OLED display, so you can see no soldering, just plugging and playing, and you can get a project up and running. That is my product pick of the week this week. It is the Cutie Pi SAMD21 Cortex M0. Hey, it's starting all over again. Well, there it is. I found it. Set that down. I don't need that in there anymore. I noticed over in the chat someone was mentioning Xbox controllers and arcade buttons for assistive technology. I actually did a project a couple years ago using the really excellent, let's see, where is my Learn? Let me bring up a Chrome window for you. Actually, I'll just put that in this one. Hold on. Let's go to this Chrome cap right here. There's a Xbox adaptive. Oh, let me go to Learn. Xbox adaptive controller that was designed for assistive technology, adaptive technology needs. So that's the controller, and you can see it comes with a sort of standard sized D-pad and a couple other buttons. Then it has a couple of really large buttons, and then it has a bazillion 3.5-inch mono jack connectors on the back that you can use to hook up any switch that you want. So in the guide there, I used some, I think, arcade buttons, some foot pedals. You can see there a really large button. What else did I have in there? Some little limit switches, which are really low force, so depending on your needs, there's a little foot switch, hefty on-off switch if you want to just leave a button pressed. So that thing is really cool, and you can see the sort of bread and butter for the project for me building this was a lot of different arcade buttons. You can also use analog inputs with this for some of the, I guess like the trigger type of buttons you find on a modern game controller that's usually an analog input for things like gas pedal in a racing game. So for that I hooked up a couple of potentiometers or a joystick for that. So anyway, that's a really neat thing that Microsoft did, was building this as a really inexpensive platform. I think it's $100 for that controller, roughly. If you look out in the adaptive technology world, these things cost so much money, and then every peripheral costs a ton of money. A lot of them are built to last. They're really ruggedly built, so I don't want to diss them. But if you're looking to do adaptive technology stuff and roll your own controllers, that guide will help you maybe get started with that if you're interested in those things. And I think that Xbox controller will work on a Windows PC as well as the Xbox. I don't know. I don't think. I can't remember if it'll work. I think it's just Bluetooth, but I don't know that it would pair with other controllers. If anyone knows, let me know. That's an interesting question. Is what else can you hook that up to? All right. So let's see. Oh, Skur was saying in the chat, I was thinking of one shaped like a normal Xbox One controller, but like 4 times larger. That would be a lot of fun. Just a big, like the Duke. All right, let's see what else. Hey, let's do a CircuitPython parsec. CircuitPython parsec. Okay, let me bring up this window here. So, this is one I realized I don't think I've ever done, and if I have, let me know. But I think this is a new one, and it's I think a good one because a lot of people are really familiar with NeoPixels. But what I wanted to show today on the CircuitPython parsec is how to set up DotStar LEDs. So DotStar LEDs are very similar to NeoPixels, but they use 2 wires instead of just 1. For their connection to your microcontroller. They have data and clock. What this does is it opens up a lot of boards that can run them without the timing restrictions that are necessary to run a NeoPixel, and they can be run much faster, so you can do things like persistence of vision projects. So here's how you set up DotStars in CircuitPython. First of all, you import Adafruit DotStar as DotStar. Then I'm setting a variable numDots that says how many I have. So you can see here I have a little 64 64 DotStar grid. And then I'm creating the dots object by saying dots equals DotStar. I'm setting the clock to the board SCK, so this is running over SPI. And I'm setting the data on MOSI. Then I say how many dots I'm using, the brightness I want to start at, and if I'm using auto write. You can use this on regular GPIO pins as well, but it is much faster running it over SPI. The next thing I do is have a little random color generator, and then in my main loop here you can see when it runs it's going to pick a random color for every dot there and display that. And you can see I'm putting that under a little diffusion there, so make it a little easier to see on camera. You can see these are running pretty fast, and I'm actually putting a delay in here. Now you can also do things like instead of hitting every individual dot, we can just run the whole display all at once. Let me save this over here. So now I'm changing all of those, and you can see it's just running blazing fast here. You can see it just kind of flickering because it's running so fast. If I put a little bit more of a delay in here, you can see the effect a little bit better. And so the call for these is simply dots.fill, and then I'm giving it a tuple of RGB colors. Or in the case of individual dots, I'm saying dots dot, and then anywhere 0 to 63 in this case, you can call out one individual dot and set its color, and then we get the multicolor effect. And so that is how you can set up and use DotStar RGB LEDs inside of CircuitPython. And that is your CircuitPython parsec. Where did I go? There I am. These are really neat, by the way. Let me show my downshooter. This is a really cool little grid. I was just trying to hold it in place with those wires there like staples. But you can see here I'm running off of a feather, and then I've got my little DotStar grid. These are really flat. You can surface mount these essentially. I went and added some header pins there so I could plug it in just for this demo. But you can see these have just 4 little pads there to plug in your power ground and the two data lines, both in and out, so you can chain these together and make bigger strips of them. These are nice little mounting tabs on here, and you can snap those off if you don't need them, depending on your project. But those will lie perfectly flat if my little header weren't in the way there. And they're great for things like wearables, jewelry, small props. You can do sci-fi types of displays with those. In fact, one thing I really like to do is to set one of these colors, let's say red. I'm just going to leave that at 0. And now we get sort of just greens and blues only. It's one of the things I like to do. Makes it look a little more intentional than doing all rainbow colors at once. There's a nice pinks and magentas and reds and blues. And we can also do reds and yellows and greens like that. So that's a little bonus trick there I like to do rather than full rainbows, is just pick 2 color components to adjust. Todd, someone says, it looks a lot easier than programming those pixel purse displays. It'd be cute to make a little coin purse with one of these things. And I have coin purses on the mind today because of this arcade stuff. I actually had to grab a little coin purse full of quarters so I can see if I can get that working on the arcade game. All right, let's see. What else do we have? I think this is a good time to jump into what's going on with this Frogger project. So let me unplug this and put this away. By the way, I have one of the reasons I had DotStars on the mind. If you look at my back of the workshop there where Lars is hanging out, he's chilling with that big 255 neopixels. It's not neopixels, it's DotStars. So that's a big, huge thing of DotStars there that I have under a piece of acrylic that I was running on my Tuesday show. You can see that right there, running through all of its beautiful 2-color component patterns. And yeah, Jim said, nice CRT collection. So a couple of those are just black and white. One of them, the one up on the stand there, is composite only, but this one's been really helpful for this arcade stuff because it has RGB sync as an input on BNC connectors. So that's a Sony professional video monitor, PVM, used for things like confidence monitor in the field for video assist on film recording or inside of a studio van, a remote van, that kind of thing back in the CRT days. But one of the nice things about that one and a lot of the PVMs and BVMs is that it has a bunch of different ways to get video into it. So they'll usually do both PAL and NTSC, composite, S-video, YP, PVBR, and RGB sync. So that's what I'm using because that's what the arcade boards have coming off of them. So to catch you up, last week I kind of did the very sloppy-ish solder wires to the edge connector of a arcade PCB. So this is a Konami Scramble board that was modified at one point to run a Frogger knockoff called Frog, hence today's title of the show, Frog Harness. And despite my coupon code of JAMA today, this was pre-JAMA. This was a, 32-pin connector that was consistent among a number of Konami boards, Konami Classic pinout. So front and back side or parts side and solder side are different pins running to your different power rails, your ground, all of the input buttons, sound output, and the video output. So there's the 4 channels on there for red, green, blue, and a sync signal. And I got that working-ish last week, but I was having problems with it resetting anytime I really tried to play the game. And so what I decided to do was get a proper power supply, because I had suspicions that the bench supply I was running just couldn't provide enough current. I don't have the full specs on this board, but typically the 5-volt rail on these boards is spec'd for up to, what, like 12 amps. Rarely would that get used, but I was hitting a limit at like somewhere around 2.75 amps. I just wasn't providing enough current. So I got a inexpensive, proper power supply and wanted to try that out. But since I had soldered wires directly to the board last week, that was kind of a little bit of a pain to swap things out or try different boards. I have duplicates of this board. So what I decided to do is build a harness. And if you look at what I've got in the downshooter over here, let me switch that to, let's go to that view there. This is what I used to essentially build my own wiring harness for the Konami Classic Standard. So first of all, I grabbed a edge connector. So this is a 36-pin, what did I say before, 32? It's 36-pin edge connector. So it has separate connectors that are solderable there to a edge mount PCB. And that means I can plug that into the arcade PCB like that. It's kind of a tight fit, but I'll wiggle that on there. And that typically would have a whole ton of wires coming off of it, bundled into little sections for the subsystems on the board. Usually with either like a spade connector or just soldered directly, and hopefully with some heat shrink around it so that things aren't too likely to short. And you'll see, if you look up a JAMA wiring harness, you'll see just a big umbilicus of wires coming off, and then some branching off to power, some branching off to the coin collector and coin display, some going to the joystick and buttons, some going up to the sound, stereo sound, or sound speaker. And I decided to actually go a little fancier than that and a little easier for me to wrap my head around and keep from getting confused. And I bought this for like $1.95. This is a breakout for a 36-pin edge connector. And so what I did was soldered that to the pins of the edge connector, and then I'm able to either solder wires to this or pin connectors so that I can run that off to different things and try different stuff, swap out my connections, and keep it all reversible and modular. So this is just a breakout. Sometimes it's called a fingerboard breakout. So this is a fingerboard breakout for a, I forget the exact spacing on these, I can look that up, but for whatever that spacing is of edge connector, and these come in different sizes for like 44 and 36 and 55 pin. There's a number of different sizes. So with that put together, I was able to do this, which is I put some, let me zoom in here. It has a non-standard spacing down here, but I was able to basically take a header pin and yank the middle pin out and fit in header pins that I could then plug in these DuPont connected cables out to my different power rails, ground, the video, and so on. So I'll go through, for a second here, I'll go through what we have. This is a pair of power connections. We have a negative 5-volt and a plus 12-volt, and then we have two positive 5-volt connectors here. And what I got is this, which is not plugged in right now. I got this for about $30. I'd probably be better off with a Meanwell power supply, but this is what I got, quick and easy off of Amazon. This takes in 120 AC, and it gives us a 12 volts at, they're claiming up to 4 amps, the negative 5 volt at up to 1 amp, a couple of grounds, And then this one is the plus 5 volt up to 16 amp. It also has a crude output adjustment, which lets you tune those a little bit, but it kind of robs from one to give to the other. So I wanted my 5 volt to be 5 volt or even just slightly above that. That is the pickier one. 12 volt I think is mostly used for the audio amp, and negative 5 volt, if it's used at all, is usually an audio thing. I don't think this board needs it, but it can vary by board if it needs it. So now I've got those connectors that run to their proper spots on my little fingerboard here. And then I have, for now, actually only hooked up a single set of controls. So you can see most of this center section is running to 4 buttons that I have here and a joystick that I have here. So one of those buttons is actually meant to be the coin collector, and I think we're going to try and experiment with that in a little bit. But you can fake it with a button just by kind of tapping that to pulse, and it'll make it think that it's gotten a coin. These are per player. The standard in JAMA is you get a start button, player 1 start, and a player 1 button A and a player 1 button B. There are a bunch of unpopulated pins on there. That would be a duplicate of all that stuff for player 2. I think even coin, because some coin doors will have the 2, although usually I think either person can use those as credits, but I could be wrong. And then 4 of those pins are out to the joystick, so that's running to the joystick there. And I made a little intermediate board here so that I could plug in on 0.1 inch spacing some of these JST connectors that work with our arcade buttons, make that easier to plug in, and a bunch of ground. So I have ground running to everything that wants ground, which is all the buttons want their own ground and the joystick wants a ground. And then finally I've got these for here running to red, green, blue, and sync, as well as ground, out to the monitor. So for that I have B and C connectors, which maybe I can turn it around and show it later, that give me the signal to the monitor. So that's that setup. I'm just going to pop open my Discord here so I can see if there's any thoughts or questions before I continue on. And okay, no, we're good. Okay, so here's how we set this up. You can see, by the way, this is my board that I was using last week. It still has some blobs of solder that I haven't really cleaned off, but the connector does fit onto there. So I can plug that in like that. And like I said, that's how an arcade operator would connect a new board or a swapped out board into the cabinet. So this really represents the wiring loom that goes to everything else. So that's kind of nice and plug and play. I'll zoom out here so you can see a little better what's going on. And I also this week plugged in, I didn't have a speaker going last week, but I've taken again, I'm not sure on the specs on this. I just risked it and it happened to work. This is a 4 ohm, 3 watt speaker. I plugged that into the audio outputs. There is an amplifier here. I think it's mostly under this heatsink. And there's even a potentiometer there that I haven't touched because the audio is fine, but there is a potentiometer there that can be used for changing volume. I think on some cabinets there'd be an actual potentiometer available with a knob on the back maybe for the arcade operator. And I don't know if that's a bodge or a hack that you could do with this board, but for now you just use this pot to change that out. And so if you look on this monitor here, I'm going to go ahead and I don't have any fancy on-off switch. I just plug in the power to this power supply. And you can see here, this is booted up. Let's switch over. And I'll go ahead and turn off, let's see, do I have the remote for that? Yeah, where'd you go, little remote? No, you're not over here. All right, let me just flip that one spotlight off, which will make this look a lot brighter. There's still some reflections in there, but hopefully you can see that well enough. So this is, if you weren't here last week, this is a Scramble board from Konami that had a bootleg Frogger called Frog put on it. It's believed that that was the real Frogger ROM, which was extracted and then hacked a little bit to do a color change on it. So you'll notice the colors are weird. I don't think that's because I've swapped any color wires around or anything like that. It was just a weird, I don't know why, someone decided to change the colors of Frogger. Make this game called Frog. And then there were some modifications done to the board. You see there's a number of bodge wires on here that I think were part of getting the Scramble board to accept the Frogger ROM. But if I go ahead and put a coin in it here, hey, we get some good sound. You can hear that that's the successful coin insertion sound. This red button here is what I'm using for player one start. Hey, we get our... and now I'll try to play it backwards in the reflection or the monitor here. I can barely see that frog. Oh gosh, yeah, I've gone into the drink. Oh, yeah, my delay with the camera thing is, I'm probably not going to be able to get a point. So let me plug that back in so it doesn't play. It doesn't play a song during the attract loop, which is interesting. Another interesting thing is that I have a set of dip switches on the board here. I'll turn that light back on and I'll switch cameras. If you look right here, you can see there's this set of dip switches marked 1, 2, 3, 4, 5, and 6. These are used in Scramble, for example. The positioning of these dip switches is used to determine, I believe, how many lives the player gets per quarter. And there are a few options you can do there. I think it's 3, 5, and 256 or something like that. And then it can vary by game. So for this Frogger, and I think maybe for Scramble, but for Frogger, this could be both a upright cabinet or a cocktail cabinet where it's built into a table. You can play two-player on the upright just by saying, okay, it's your turn, and someone uses the joystick. On the cocktail cabinet, it was built with a joystick on either side for Frogger, I think. And so when it became player 2, it flipped the graphics upside down and switched which control was being used. I think there's a combination of these that does put this into cocktail mode, because when I was testing earlier, I saw the screen flipping itself upside down and right side up. From what I read, it's kind of hard to find out because I think there's a transposition from the Scramble board to Frogger ROMs that are hacks that is not anything I found in any manual so far. I do believe that whatever arrangement I have right now is giving the Frogger player a ton of lives, because my son was in here playing it earlier and I noticed he went through like 6 or 7 lives and the game didn't ask for a new quarter. So I think that's the first 2 switches here are might be the number of lives per quarter. So I think that might be all you can do is number of lives. Oh, and also free play. I think it might be possible to set free play. I don't believe the 6th switch is used, but I think the first 5 are. So combinations of those are going to be my next mission to figure it out. Also, you can see here while I've got this close-up, here are some of the aforementioned bodge wires that were added to, I believe, trick the board into playing Frogger. I think if I were to get a set of ROMs to swap out for Scramble, the original, I would need to reverse all of that, basically. And I think in most cases, it was non-destructive. I didn't notice any cut traces. I think it was just making connections that, to pins that weren't there originally. I noticed in the chat, C. Grover loves this, resistor polarity uniformity. Not flipping those back for you. It's not, you know, they're not polarized, but the color order is red left to right. So when someone is putting a board together and paying attention, you get this kind of nice arrangement here. So another really thing I'm really happy about is now, I wasn't sure before if I had 3 working boards. I got 3 of this identical board. Now I can test that out, and I have. So if I take that board there out and swap in that one there, now I can just plug it in. I wish it were a different game, but it's not. It should be identical. I do have a different arrangement of dip switches on this one, but I don't think that's going to do much anything. So now I have a different board in there, and I should be able to plug that in. Oh, I had it plugged in. All right. Thankfully, I didn't break anything. I didn't realize I still had that running. That's the bad part about me not looking at the monitor and it being perfectly silent when it's in a tracked loop. And there we go. All right, I'm going to get one. Ah! No, I'm not. All right, I'll plug that. So the next thing I wanted to do actually with this is try to make it a little easier to play. So you can see I've got this little mini joystick that I'm just kind of holding. I have done a couple of arcade projects that have left me with some empty prototype boxes in the past. This little cigar box that I had actually mounted an Arduboy on and taken over, if you're not familiar with the Arduboy, it's this little, in fact, this is the very one. So this is kind of a gutted one. This is little handheld game player, and I mounted it and took over. There's nice pads on the back there for taking over any of the controls. So I had used the joystick and a couple of buttons to make a very small game, have some very big controls. But this has 2 buttons connected on it, same little lug connectors. So what I'll do is I'm just going to mount the joystick and the 2 buttons that I'm using into here. I think I'll have the clearance that I need. So let's just put that together. That should be pretty straightforward. And I am unplugged now. And, you know, typically in an arcade setup, the different parts would just be kind of bolted on the inside of the arcade. So this is kind of in keeping with that idea. I've got parts kind of strewn about. I may have mentioned, these spade connectors, by the way, are not easy to pull out. Let me grab some pliers to do that with. I think I mentioned there are some really neat products out there that usually go by the name Super Gun. Come on. All right, how do you get these off? These are really on there. I don't want to break it. There we go. You just have to commit. All right, so that one is going to be my coin. I'll just use the red one for coin. So the Super Guns take this concept and put it into a nice little neat enclosure and give you usually a SCART connector to go to your RGB monitor or other. Some of them will have a converter in there so you can get S video out or other component, other types of video. And they'll often have jacks for plugging in regular controllers if you just want to use, I think there's maybe some standards of like a Neo Geo controller port that might be like a DB9 or something. Some of them will just have ports that you can use more modern game controllers with. So those look pretty neat. I was investigating them, but by the time I got this built and working, I decided this may be enough for me. I'm not really sure if I'm building a cabinet here or what the heck I'm doing yet, but mostly just having fun. All right, so those two buttons should now be part of that party. And then this is up the way I've got it wired on this joystick. So I'll have to, with this one, I'll just have to kind of turn my box this way to use it vertically. Or maybe, how about the other way? Let's do it like that. That'll be the vertical orientation. And then I've just got some M4 screws and nuts here that I can put into there. Oh, did I leave that little, yeah, let me get that white disc. I'll put that on the top. Doesn't go there. Yeah, Todd, I agree. Old cigar boxes are really classy, fun project boxes. Todd wants to make a Frogger game with a Kraftwerk soundtrack. Ooh, Paul Cutler, you're working on an arcade cabinet. That's cool. What are you building? And is it modern, like with a LCD? Are you using a CRT in there? It looks like a lot of the classic games have a roughly 19-inch CRT tube in them, from what I've seen. I've got a few 20-inch CRTs that I think could be modded to use RGB input, which would make them good candidates for an arcade cabinet. All right, so I think what I'll do is just kind of hide all of this jazz, all those connectors under here. Actually, you know what, it'd be safer. I don't want to unplug stuff by accident. So let's see, maybe like that might work. Get that into there, that's a nice sound. And let's put our ball back on the joystick. Let's fire this up. You loved that sound. Okay, let's, I guess I'll leave it connected like that. You know what the Frogger looks like. So here's my coin. Hey. Player start. Yeah, that's better. Now I've got, okay, now I really can't see it. This is going to be the time. This is going to be the time that I'll make it. No, I'm not. All right, let's unplug that. So now, the other thing I wanted to try out is this is a project I put together years ago, and I think I have a guide up on it. So we sell these coin collectors in the Adafruit store. So it's a full coin collector assembly. I built the case around it, but it's the full mechanism for collecting coins. And the way it works, I do need a mirror, Andy. The way it works is it gets there's a bunch of dip switches on it to say what you're kind of trying to do, but you put it into a training mode, and I think I put this in the guide. Once you put it into training mode, it wants you to feed in about 40 to 100 of the coin that you're trying to train. So I trained it on quarters, and that way it will reject things that aren't quarters. It has a power, I forget what, might be 9-volt power that it's running off of. What are you? Yeah, 9 volt. So I've got a 9-volt power running to it. And then it has a ground and data pin output, which send a pulse. This thing has a startup noise, that little beep. It sends a pulse over that data line when it's received a coin. I don't remember what that's set to, if it's something I set, if it's something I changed so that I could use it because I was just using it with like a Raspberry Pi on a little Picade. But I decided, what the heck, let's try plugging it in where the current coin button goes and just see if it works. So I'm going to look, let me flip back to this camera. I'm going to look at where this wiring is going right now. That's going to be this blue here. Okay, so what I can do is I can unplug from the board this line right here. I'm going to just double check it. Yeah, so that's it. So this line right here, and instead I will plug in the coin receiver's output pin, which I believe sends a little 5-volt pulse when it receives the coin. And then I need to hook into ground. Do I have a spare ground I can use? Where are these grounds going? I think I can grab one of these. These are two that are both running to the power supply. I don't believe I need them both running to the power supply. So I will take that one over there. And hopefully I don't blow everything up, so let's see. So I will power this up. And I mentioned coin purse before. Borrowed a very cool coin purse from my daughter. And I have a bunch of quarters. So let's see if this happens to work. It would be great. I also have no huge high hopes that it will. Let's see. Yes, it did. It totally worked. It lands with a thud inside of there where you can collect them. Let's put 2 quarters in. And apparently back when I tested this, I had a 2 franc coin that I was probably testing to see if it would reject it. Let's see if it rejects it. It does not reject it. Okay, I don't know if I have to retrain it. I don't know if that's lost all memory of what was acceptable or not. You might be able to put any washer or slug you want in there. That's kind of fun. I don't plan to charge for this. That's highly illegal. I'm sure the state of California would freak out. But now I can put coins in to start it up, which is much cooler than a button. How about that? All right, this is the one. This is the time when I'm gonna successfully play Frogger through a reflection of a monitor. No, I'm not. All right, I'll turn them on. So let me unplug that just for sound. So what I'll do, wires are going to get tight here a little bit, but what I'm going to do is turn the monitor around so you can see. I said I'd show you what the back of that looks like, and then I'll be able to see the game, and you'll at least probably hear me successfully get a frog in there. Right? This monitor, by the way, is on its side because that's the orientation that Frogger is in. It's a vertical game. A lot of monitors don't love being shift it around, they'll lose calibration. I think this one's pretty good at it just because it's a fancy professional monitor. All right, so I don't have a good way to share that with you, so you'll just have to listen to the resounding Frogger success of me getting that in there. But you can see, yeah, you should be able to see there. These are the red, green, blue, and sync connections that I have going to BNCs back there. All right, so let's pop a quarter in. Hey, it didn't register that. It says credits 0. I think it might not be sending enough pulses, so I think I need multiple quarters to, yeah. So 2 quarters is enough pulses for it to register 1 coin, which is interesting. All right, so I have 1 credit. It's so much easier this way. Ba-boom! You will see my triumphant 1 frog up at the top there. There he is. All right, I won't attempt to do that again backwards because the lag of it going through a camera and back is too difficult. All right, so let's see. Any thoughts or questions that anyone has about that? Let me know. Time to make my own tokens. Expensive game, yeah. It requires 50 cents for one play. Although, like I said, I think it's somewhere over 5 lives. I'm sure my son went in the water for like 5 times because he didn't realize where you were supposed to go. Kids today, they don't actually know how Frogger works. So poor kid was trying to jump onto like the land parts up at the top. Let's see, what else? 2-player stand-up arcade Paul's building. Modern, yes, with a LCD. That's smart because CRTs are ridiculous and a constrained resource and very heavy and annoying. Yeah, good. All right, so we've got it working. I don't know if I will mess with trying to put other ROMs on there. There is a ROM hack that someone wrote that converts these ROMs to it just edits a couple resources and it says Frogger instead of Frog. And I don't know if it puts the copyright back at the bottom. I think this is supposed to, even though Konami made this game, it's, I think, copyright Sega. I could be wrong on that, but I think that's what I've read. And then I don't know if it color shifts it back to normal colors. It might just be stuck on these weird ones. I would love to get Scramble on here. It's a really cool early Defender-like sideways, like a horizontal shoot 'em up, which apparently pioneered both having the concept of levels and not just being kind of getting your high score by going endlessly in a horizontal game, and the fuel. There was fuel pickups you needed to do to keep going. So Scramble's cool-looking game, really cool-looking cabinet. That's what this board is from, so maybe it could run it, like I said, with the proper ROMs and maybe getting rid of some of those bodges that were done on it. So I, at this point, need to figure out what the heck I'm doing with this, if I'm going to try to mount it into some sort of skeletal version of a cabinet, maybe get a real-sized monitor. This one's good for testing stuff, but it's not that much fun to play on, so get it up on a larger monitor would be fun. And I actually want to know what you think. If you've got ideas on things to do with that, some fun potential hacks for playing that, what could be done. The other thing actually I wanted to do, and this was Katney's suggestion, a couple things I meant to mention with the. Let me jump back to this screen for a second. Go back to my little down shooter here. Yeah, one thing I wanted to mention about this is that I was talking to Katney, and she said the warm white DotStars that we sell actually are on the proper wavelength to be used as grow lights for plants, as are the blue and the red. So part of the sending different wavelengths to tell the plants that it's day and night or something like that involve the red, blue, and warm white. And so if you look at those warm white DotStar, not NeoPixel, the warm white DotStar strips that we have, they're actually working really well as grow lights. And Kattni has an upcoming guide on building a grow light system using DotStars, so look for that. And another suggestion that Kattni had is, if you want to let me know things you'd like to see in upcoming CircuitPython parsecs, if there are topics you'd like to see me cover, please let me know. I believe today was the 90th episode of those, so I haven't run out yet, but I would love to hear if you have specific things that you'd like to see in the CircuitPython parsec. So go ahead and leave a comment on the YouTube video when that goes up, or right in the Discord or YouTube chat, and I'll check out your suggestions. Let's see, what else have we got? Any other stuff going on in the chats? Mod it to accept Apple Pay or Bitcoin. Oh, a huge projector, that'd be kind of cool. Have you seen those giant LED matrix versions of Space Invaders and Pac-Man that they have at arcades now? They're amazing. It's like an 8-foot high wall of LED matrix panels that are playing some arcade games. Are really cool. All right, I think that's going to do it for today. Thank you everyone so much for stopping by, and I look forward to working on this and some other cool projects coming up. I'm also working on the Hex keypad guide for the little Hex pad, and I keep threatening to finally finish the LCARS display. I have some woodworking to do, so I'll hopefully get that done sometime soon-ish and be able to show that to you all. So thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye. Oh, and before I forget, 10% off in the store today using JAMA as your coupon code. So on the way out, go buy some cool stuff. This works on things. It won't work on gift certificates or subscriptions or software, but on physical goods, you can get 10% off on your order by typing in JAMA. So go ahead and use that today. Thanks everyone. Bye.
Thank you.